Well, good morning, everyone. We have 3 talks this morning, and we're allowing half an hour for the talks and 15 minutes at the end of each talk for questions. We have our first speaker is Dr. Barbara Zipser from Royal Holloway, University of London, and she's going to talk about, as you can see, error of judgment in ancient theories of the cosmos and atmosphere. So I'm looking forward to that. Over to you. Thank you.
Yeah, thank you very much. So I just wanted to give a brief overview over the reasons why people may have made errors in the history of science, but also in means of progress and regression. I think that makes more sense rather than going really in depth in primary sources about individual problems. So my talk is divided into 2 parts. The first on the effects of stars and planets, or perceived effects of stars and planets in ancient Greek science. So let's start with prehistory. So this is a picture of Stonehenge, clearly an astronomical installation. And if you decide to build anything like this, you think twice. And in particular, if you are then also going to transport these stones over a long distance. So why did somebody come up with this idea? So basically, several thousand years ago, this stone circle was built, first constructed in Wales. It was then transported to Wiltshire, and it looks similar to other astronomical installations in other fairly distant parts of the world. And this suggests that there was a coordinated effort and a tradition that span across a long time. And a medieval text, so several millennia later, suggested that Stonehenge was actually originally a medical installation, that they washed down these stones and used the water to treat people with certain illnesses. So to what extent can we actually believe such a story several millennia later? Today, memory extends our personal memory, possibly, our life until perhaps primary school. And then we know a few facts about the lives of our parents. With the grandparents, it already gets sketchy, and usually we do not have these full facts. It was very, very different. And in particular, at the beginnings, when writing was not that well established, or when there were just oral traditions around. So if someone says in the Middle Ages, well, Stonehenge was a medical installation, can we believe this? Actually, in my opinion, yes, because we see these oral traditions that span a long time, also in other sources. So here I have a text by Claudian called The Rape of Proserpina, which describes one of these traditions. So it says, Sicily was once a part of Italy, but sea and tide changed the face of the land. And then a god came and flooded everything in between, and now they are separated. So Italy and Sicily are no longer connected. Now this is actually a historical fact. They were once connected. So this text from the 4th century AD actually describes the Ice Age and the situation back in this day. There are several other those instances where we can verify, yes, memory did stretch back further in time than one might usually assume. So one factor that's often overlooked, look at the Cyclops story in the Odyssey, which describes, let's say it is a subtype of humans that has just one eye. Now we know today that Neanderthal civilizations did have pronounced bone defects due to inbreeding, and that they persisted longer than one might have thought. So I personally think that is yet another such example where historical detail is buried in a text, but it's not usually recognized. So now moving on to the development of astronomy and what we can gather from written sources. So here is one of the longer written sources at the beginnings of Western civilization, the Iliad, and the author compares a historical figure to a star. So he says, Achilles looks like this specific star, and he describes the star as, brightest of all is he, yet withal is he a sign of evil, and bringeth much fever upon wretched mortals. So what do we have here? So the star is the brightest, he is a sign of evil, and he brings fever upon humans. So this extract contains a correlation-causation error. A star appears at a time of the year when there is a rise in fevers. The weather was very regular at the time, and in this area, in the Mediterranean, they could predict epidemics very, very well. It is a skill that we lost today, by the way. So we could use data such as humidity and temperature and airflow and several other factors to predict when healthcare services would need to provide for for a rise in certain diseases. We do that with the flu, perhaps, but it's not utilized properly. So they were far more advanced in classical antiquity. So here you have such an instance. They knew at this time of year precisely that's when we are going to see a lot of fevers, and at that point that star appears. And the conclusion was, well, we all know that the sun has a clear effect on our life. The moon, if we look closely, pay attention, yes, it also has an effect on our life. So all the other stars and planets also must have some sort of effect, but it's more difficult to interpret. And here we have one of these, precisely such an error mentioned in one of the earliest written sources from the Western world. So in my opinion, this error pattern goes back quite a long time. So Stonehenge, okay, we just have these two sources. It's clearly astronomical. We have the medieval source that says it was originally a medical installation. Yeah, so in my opinion, there is a long tradition where they thought these stars, they must have some effect on our health and our life. So now moving on to the second part of my talk, the shape and content of the cosmos, so to speak. So what did they actually know? What kind of astronomic theory was there very early on at the beginnings, and how did it develop over time? So again, going back to the Homeric epics, 8th century BC, we're now with the Odyssey. It's probably slightly, a tiny bit younger than the Iliad. And here we have a geographic description. So Odysseus is trying to get home. He's on a ship. Things don't work out for him. There are the gods against him, and he can't travel this fairly brief distance home. He has to take detours around the world. This is geographic data, and it was the Odyssey was regarded as a serious geographic source back in classical antiquity. It's just today that it's largely regarded as fiction. So what do we see here in this text? All the day long her sail was stretched as she sped over the sea. And the sun set, and all the ways grew dark. This has just to do with the way things are narrated in these early epics. And she came to deep-flowing Oceanus that bounds the earth, where there is the land and city of the Cimmerians, wrapped in mist and cloud. Never does the bright sun look down on them with his rays either, when he mounts the starry heaven, or when he turns again to earth from heaven, but baneful night is spread over wretched mortals. So what kind of, there's lots of information in this text. So what is going on here? So he travels through the Strait of Gibraltar, and there is a place with permanent cloud cover, and it is within the Arctic Circle because there's no sun all day. It's a flat Earth model with the sun moving in an arc. So basically, in 8th century BC, we have this flat Earth model. There's the ocean surrounding everything, and the sun is moving like this in an arc shape. With regards to the city of the Cimmerians, lots of people are confused by this, but it's actually quite easy to understand, I think. So by exclusion, what kind of areas do we have once you leave the Strait of Gibraltar, where there is the Arctic Circle? I mean, by exclusion, this means the northern end of Norway. That's the only place where we see at this time any more advanced settlements and civilizations. So it's a settlement with a sort of political structure that is described in that text. So the Cimmerians originally lived in the northern Caucasus area, and we know that at the end of the after the end of the Ice Age, there was migration to the northern end of Norway, and this text obviously describes, is a historical witness that the Cimmerians actually made it there. So apparently one of the tribes that migrated then set up a higher developed civilization in the Arctic Circle. So, but what kind of scientific sources do we have? So here's one that I find quite curious. It is from a biographical collection by Diogenes Laertius, and he describes Anaxagoras and his opinions on physics, and the text doesn't tell us more about the rationale and how Anaxagoras may have come to these conclusions, but it says that Anaxagoras said that there were dwellings on the moon and hills, and that basically that the entire universe is filled with atoms. So that's what the text means. Basically, the same as you can grind down gold to fine dust until you can't divide it any further, and that's then an atom. So the entire universe is also filled with atoms. We don't have any explanation. It's an early Greek scientist, so this is his opinion. And then he goes on to say, in the beginning, the stars moved in the sky in a revolving dome, so that the celestial pole, which is always visible, was vertical overhead, but subsequently the pole took its inclined position. So here again we have a description of astronomical observation that stretches back millennia. So the data must have been transmitted somehow. So originally Anaxagoras said the celestial pole was upright, and then it somehow started to lean, which is a very simplified way of phrasing it, but it does have some truth in it. So here we have one of these, obviously one of these very long traditions and memories that stretch back a very long time. Yeah. Also integral to these, already at the beginnings of Greek science, we see the four-element system. So basically the four elements are water, earth, fire, and air. And then there is occasionally, whenever it doesn't, I mean the earth number is 4, but when it doesn't work out with 4 humus or 4 elements, then you get a 5th one, so that you can explain things better. But here we still have 4. And yeah, so there's, even at that time, the idea of movement, and that there are heavy elements such as earth and water. So earth and water are at the bottom, so they must be very heavy. And air is above those, and fire is moving upwards. Yeah, and these, this is then fairly difficult to, would not fit within a half-hour lecture, but this theory then caused problems, that you have upward and downward motion, and that somehow interfered with various conclusions in physics. That was sort of in the middle. We are still, so with Anaxagoras, we still had the flat Earth model. And now we are with the Pythagoreans. It might be surprising, we do not have very many sources, so no original texts. And anything on the Pythagoreans you have to gather from other sources, so other writers who mention their theories or discuss those. So here we have one that is particularly enigmatic. So how did the Pythagoreans try to explain the shape of the cosmos? So basically, they had a central fire, but that was not the sun. So there was a fire in the center, and then there was an Earth and a counter-Earth. And how that may have worked is not clear. Just to summarize, so the Pythagoreans had an unusual system, neither helio nor geocentric, and connected to it was cosmic harmony. So basically that the planets make a sound as they move. So first of all, you need a certain kind of explanation. Why do we not hear this sound? If we are here in this room, okay, so if we went outside, why would we not hear the planets move and there being sort of an ever-changing harmony? It's not explained in the sources, but there was a suggestion that perhaps we may be used to it, or that it is a type of sound that we can't hear, but that does have an influence on us somehow. And it's all connected to music theory. So if you divide a string in half, or if you divide it by 2/3 and 1/3, you get certain intervals, and that is the same with the planets, depends on size and speed and orbit, and that this somehow influences and explains then why the planets have a certain effect on us. So again, a correlation causation error that largely goes back to stars. Whenever that star appears, something tends to happen on Earth, and then the assumption, okay, so the others must also have an influence, including the planets. And coincidentally, so this is still roughly how modern day astrology works. And the sound being obviously a medium that can reach us. So obviously you need to explain why, how does it happen? If the planet moves at a far distance, why does this have an effect on us? Sound, that could have an effect. Now, coming to accurate astronomy, so the solar system as we define it today, up to Saturn approximately, was known in 3rd century BC. There are fairly accurate descriptions, and there are drawings of the solar system, so they knew in 3rd century BC. At that point, it was also totally well established that the Earth is a sphere. So the flat Earth model went out of fashion, perhaps in sort of popular discourse. You may have encountered it, but scientists knew it's a sphere. So why did this happen? We don't know precisely, but there are some sources that describe the reasoning. So basically, they had the correct system, but they reverted to a false geocentric system and somehow made it work from our perspective. Paraphrased, I mean, Ptolemy is the most influential author here. So paraphrased, it's about 3 pages long. I can't, unfortunately, present this today. So basically, Ptolemy said the Earth does not rotate. And he said, first of all, it's ridiculous to assume that we are right now spinning through space. The idea of spinning has been discussed in Greek science, that there's something about spinning for quite a long time. Yeah, but he says, no, that's ridiculous. So the 3rd century BC system. And second, if I threw, I don't know, this control here in the air, it would fly sideways if we were spinning. And similar, the clouds or anything that's not firmly attached to this Earth would fly sideways. So that was the underlying error. And this defined astronomy up to the early modern period. So basically, they had the correct system in 3rd century BC. Then it somehow went out of fashion. 2nd century AD, Ptolemy comes up with his writings, which are very data-rich as well. And that was it. There are some curious passages in the Almagest as well, where Ptolemy discusses potential shapes for the Earth, whether it's a square, for instance. But he then comes up with a conclusion, no, it's a sphere. That is the only thing that would make sense. So what other information do we have? Meteorology was often connected somehow to astronomy. So there was they didn't quite keep these two matters apart, two disciplines apart, and that could then cause problems. So I'd just like to conclude, I'd like to show you 2 extracts by Seneca from the 1st century AD, where Seneca describes halos, and he comes up with an almost correct idea about light waves. Yeah, but he incorrectly assumes that the area near the stars would also be filled with thin ether, which is something that is similar to air. So the idea of vacuum is somehow also missing. So here is the extract from Seneca. So when a stone is thrown into a pond, the water is observed to part in numerous circles, which, very narrow at first, gradually widen out more and more, until the impulse disappears, lost in the surface of the smooth water beyond. So basically, an everyday observation, someone takes a pebble stone and throws it into a pond, and then you have these circles moving outward until they sort of disappear. Let us suppose something like this happens in the atmosphere, and when condensed, is capable of receiving an impact. So the light of the sun, moon, or any heavenly body encountering it forces it to recede in the form of circles. So basically, he thinks that the light that is emitted from the sun, moon, or the stars, it moves in a similar fashion. So similar as if you throw a pebble stone into a pond. Yeah, so it's a discussion about halos. So if you see, sometimes you see a halo in the sky and sometimes you don't. Depends on the weather. And so Seneca then goes on to say, in reality, such an image, such a halo, is formed not very far from the Earth, but we can't really perceive it. So something is wrong with our vision. And we see it as something that is actually, it's an illusion that it appears to be actually close to the heavenly body itself. But he says, no, the halo actually must be close to Earth, because in the neighborhood of the sun and stars, there's nothing but thin ether there. So there's nothing that could carry such an impulse that similar to throwing a stone into a pond. So this is the reason why the halo that we see must be generated somewhere in the atmosphere rather than directly in the vicinity of the star. Yeah, it is a bit difficult to explain, but this is kind of the mindset, why they made errors, because yeah, there would have been better ways of analyzing it. So why do we sometimes see a halo and sometimes we don't with the same kind of heavenly body? And then you could discuss the atmosphere, and then you can come up with the reason that must be where it is located. So to conclude, on the whole, while there were some strikingly accurate descriptions, coincidentally they also calculated the circumference of the Earth pretty accurately. I think the error margin is 2%, with a very simple trick by putting 2 sticks into the ground and measuring the shadow, and they knew the distance between these two locations where these sticks were. They could measure that precisely, so they knew it was a sphere. They knew how big it was, but then sometimes there are still odd errors, and Aristotle at one point kind of gets not his estimation of the size where India then precisely would be slightly wrong, but still it was quite advanced. Then suddenly we have a heliocentric system that was superseded by a geocentric system with epicycles. So epicycles, basically, they thought the Earth was in the center, and and everything else. So the planets would move relative to the Earth would be similar as the Sun and the Moon. So there would be 2 orbits around the Earth, 1 orbit in a circle, and around that another one, like an Earth and Moon system idea in connection with the Sun as we have it today. So yeah. So for whatever reason, it didn't stick. They didn't believe it sufficiently, and they said, no, we must be in the center of the universe. And while the ancient civilizations were in some respects more advanced than us, we lost quite a few of important skills over the millennia. For instance, in medicine and engineering, it is also striking that this peculiar correlation-causation error persists to the day that the stars and planets must have some sort of effect on our life, and that they must somehow influence our life. And to this day, so of all the positive developments and new discoveries that could really support our life today, quite a few of these were lost, but the one that was wrong, the horoscopes, that's the one that persists to this day. So you can still open newspapers and they do have a horoscope section for whatever reason. So I don't know what to say about this. Yeah, but yeah, so this is, in a nutshell, that's the history of astronomy in classical Greek antiquity. And I'd be grateful for any suggestions. Okay. Thank you.
Question here?
Thank you very much for that. You mentioned a medieval text saying that Stonehenge had medical purposes, but I may have missed it, but I didn't see who was saying that. Were they still trying to use it for medical purposes?
It is a Geoffrey from Monmouth, and sorry, I had to skip quite a lot of content. I had half an hour, and it was, more than 1,000 years that I covered today. So I had to cut out a few sources. Yes, it is fairly well transmitted that it was originally a medical installation. We do not have any witnesses that it was still used in this respect in the Middle Ages, but it is clearly astronomical. I mean, that remained the same. The practice of washing down stones or using minerals for medical treatment was widespread in classical Greek antiquity. So that makes sense. The whole story makes sense. Also, if you ask yourself, why would anybody build Stonehenge? Why go through all this trouble? Was it just astronomical? Was it religious? Was it cultural? If there's a medical angle to this, it actually makes more sense that someone would go through the trouble of creating such a monument.
Okay, there's a question here with the chap with the orange front.
Yeah, I'm just interested in ancient Greece. Was there any sense that a simple model, a simple mathematical model like a heliocentric model, was inherently more likely to be correct than a more complex model? And when did that thought process come into human thinking, that a simple is more likely to be correct than a more complex model?
I haven't heard this. It's quite complex, and the reason why I just showed you a few snippets is because, I mean, there's a whole Aristotelian treatise, but that would take a few weeks to cover. There's no explanation for this. The heliocentric system is quite straightforward. If you think of us in the middle and then everything spinning on this axis and also in epicycles, it's more complicated. But for whatever reason, I mean, the reasons given by Ptolemy, as I said, it's ridiculous to think we are spinning through space. And if I threw this here in the air, it would fly sideways if we were spinning. So that's the thinking.
Okay, there's two questioners at the back.
Hi, thanks for the info about the generation of astrology in the West. But obviously there's astrology in China and places like that. They wouldn't have had the same derivation. Is there any connection with the Western derivation of astrology in the Eastern derivation?
I'm sorry, for China, I'm not qualified. So it does come up in multiple cultures at the same time. So, yeah. Perhaps it was a common perception. Perhaps it's also likely if you look at the stars, I mean, in the absence of anything else to do at night in particular, in winter, artificial light being expensive, you look at the stars and the planets and you wonder whether it has any meaning.
The question at the far side there, with his hand up.
Thank you. I was really interested in your first slide of Stonehenge, that the stones came from the Preseli Mountains in Wales, and Stonehenge didn't happen overnight. So I'm trying to figure out, it's a bit like HS2, what oral transmission was there to say, this is how we build Stonehenge? Can I go and ask someone else? And how was that notated over the time scale to do that? Do we have any evidence for that?
That is the problem with prehistory. We do not have written sources. We know that there were similar huge astronomical installations in other parts of Europe. But we do not know how these people communicated. I mean, there is a medieval source that actually says the people who built Stonehenge came from Africa. So it is possible. There must have been connections over very long periods of time. And I'm not a prehistorian, but a primitive writing system has recently been discovered or deciphered in cave paintings that also points towards contacts over long periods of time and long distances. So how that may have played out in practice, we do not know, because travel was dangerous. And the population size was very small. So there were actually very, very few people in existence.
Question up to the far side. Yes, thank you.
Thanks for that. Amazing, yeah, multi-millennia tour. I'm just wondering, can you comment on ideas about gravity then? Like
Yeah.
basically weight, because obviously that relates to celestial mechanics as we understand it now. Thanks.
Yeah, it wasn't well. That was the problem with the four-element theory. So they thought that it had more to do with the four elements or four humours which we consist of in ancient theory, and then inventing a fifth if it doesn't work out. So it wasn't well developed. So basically they had an idea of two elements, so earth and water moving downwards, and air and fire being the lighter ones, and fire moving upwards. But yeah, this is precisely one of the reasons. But again, that's one of the topics that, if you give me 2 weeks, I can.
Okay, a question down here at the front.
Yeah, thank you for the interesting talk. I like it when you refer to the Greeks, because I read philosophy. There seems to be in my mind, a conspicuous omission. One, the Bible, surely the Jewish nation, who are fairly good on science when you get into the last century. I don't need to mention names, I'm sure. And also the Babylonians. You've made no reference to them, but Genesis starts off talking about the planets, the sun and the moon and light and things like that. Surely that's influenced science to some degree.
Yes, well,
even pre-Christianity. Yes, I'm slightly surprised you've left that out.
Oh, it was a talk about Greek astronomy today. I just spoke mostly about Greek and sort of more the West.
Oh, right. But
I know I started with Stonehenge, but yeah, so basically with the rise of Christianity and from 4th century AD onwards, when it became really influential in the West, this is when these ideas spread more widely than with Judaism, I would say. And yes, they adopted the Ptolemaic system largely. But yes, obviously there were also religious influences. And what I also left out is that what came up right at the start a bit was about gods being behind natural forces, so that there was a god who was thought to be causing lightning, for instance, Zeus throwing lightning from the heavens, and Nero's flooding this, you know.
So are you saying before Constantine, when in the Roman Empire Christianity became the established religion, there was no Judaic influence in scientific endeavour, because they were a small nation tucked at the end of a Mediterranean? They had no influence in scientific endeavour then?
They did, certainly in their own area. It's a completely different... so with these, once Christianity became established, from 4th century onwards, everything changed. It really became...
Right.
It magnified, you know, it just spread these writings, these books, the ideas as well. Before that, there is a whole genre to be explored in the East. I couldn't. Also, the Babylonians. Yes, there is a certain tradition that Babylonians provided data and observations to the West. You have that, for instance, in the Gospel, in the Nativity story when they appear. All this. They were very highly regarded, in particular the Babylonians, for their astronomy, and it was enough to trigger a genocide, basically. I mean, that's how strong their influence was when Jesus was born, and then all the children were murdered.
Slaughter of the innocents, yeah.
Yeah. So basically. Yes, so they were very important for observations and data.
Well, we still use 360, don't we?
Yeah, and also theories. And there was a certain recurrent theme that Western Greek scientists traveled to Egypt And that's where they came up with new conclusions. So the importance of Egypt here was more of it being a trade hub with a lot of people traveling. There was a shuttle service from India, including the southern tip of India, where the stars look completely different. There was a trade route down to almost Mozambique in modern terms, and they all met in Egypt. All these tradespeople and the people who traveled there, they exchanged. Yeah, what do the stars look like from your perspective when you travel to what is today Sri Lanka, for instance? Yeah, so this is the importance of Egypt, this being a multicultural, multilingual center, a trade hub where they all met and discussed. And the Museum of Alexandria, for instance, and its importance, it was very multicultural. I had to simplify this completely because I just had half an hour. So apologies for leaving out larger parts of the world. It's basically, I just thought I'd present a few points about patterns of error for this conference because a comprehensive view wouldn't have been possible.
Thank you very much. Having the title of today's workshop is errors. Mm-hmm. So were there? In Greece, do you see the errors and the debate have been a helping factor to improve and to proceed?
The concept of error. Yeah, there's usually quite a lot of discussions, but some errors just persist. So for instance, the four-element theory persists. It's difficult to answer. I wouldn't say it is central to it, but they do discuss all sorts of topics.
Okay, I think we need to bring this to a close now.
Was someone in the front row here?
We've just got enough time.
Okay, yes, thank you very much. My question is this. We presume that when we read an ancient text, that the people who wrote it aspire to offer a causal explanation, because this is what we search now. But is that true? Because I'll give you an example from naturopathy. There is an association between broccoli and the lungs, because broccoli looks a bit like the lungs. Now, it's not a causal association, but it's used because people find it easy to remember, and it's true, by the way. So would ancient text be more preoccupied with long-term memory, and you said the effective of that, rather than actually identify a causal explanation? And if this is the case, what do we do when you approach an ancient text to understand whether that's what they want to do or not? So the slide after this might tell us, because it's after that, the one that talks about the stars. So it's not the first slide, but anyway. Okay, yeah. So it is possible that all people wanted people to remember was when there is Orion in the sky, watch out for that. It's not that it causes it, but it's a good way to remember.
Yeah, so this text was probably sung. It was not written down right at the start and when it was performed. So it was, we do have these connections in the history of medicine, that you treat something with a certain plant that looks similar. And sometimes there is a certain truth to it, we will later find. With regard to memory, written culture developed very rapidly at that time. And again, it depends on where you are. Just coming back to the previous question, in Egypt you can use papyrus because it keeps in that dry climate. Very cheap. You can start to write yourself. If you are elsewhere, have to use parchment. That's expensive. So it's difficult. Sometimes we do have poems that list information, and this poetic format makes it easier to memorize. This is definitely the case. Also physics, we have at least one physics manual I can think of off the top of my head that is written actually in verse. Just because this is somehow, if you memorize things, verse is easier to memorize. like this text here, for instance, as well. Yeah, it's a complicated question, and it depends on the spread of writing that was available. I think at the start, we also don't know how the original data was recorded in prehistoric times, obviously. So I think that they would have had both oral traditions and written traditions. I'm more of a medical historian, and in medicine, the written knowledge spreads. I mean, there's a clear spread in writing.
But if that was the case, if they wanted just to trigger memories, if the only thing they wanted was to trigger a memory, then our interpretation of the word bringeth has to be careful and say bringeth means, look, there's an association, remember. It doesn't mean it causes it. Right? So it's not their error, it's our error. Because we don't interpret right. Could be, I mean.
It is the Greek word. It's a translation. The original Greek word suggests it causes it, and there are plenty of other such sources that the disease is actually caused by that star rather than it happens to occur at the same time.
Do you remember the Greek word?
Sorry, no, I didn't. I thought I was. I'm sort of completely thinking about English translations, because I thought this was an audience that was mainly
it's okay.
Anglophone.
Thanks.
Yeah.
Okay, I think that's very good. Thank you very much indeed.